find the limit. The limit of x times 3 to the x divided by 3 to the x minus 1 as x approaches 0. If we try the quotient rule here, we would take the limit of x times 3 to the x as x approaches 0 divided by the limit 3 to the x minus 1 as x approaches 0. These are both continuous functions, so we may substitute in the number to calculate the limit. Zero times 3 to the 0 is 1. 3 to the 0 is 1, so 1 minus 1. 0 times 1 is 0. 1 minus 1 is 0. So we have an indeterminate form, 0 over 0. The quotient rule fails. However, since our original limit, the numerator and denominator are both differentiable, we may calculate this limit or evaluate the limit by using LHopital's rule. So by LHopital's rule, we have that our original limit is equal to the limit of the derivative of the numerator divided by the derivative of the denominator. That's what LHopital's rule says. In the numerator, we have a product, x times 3 to the x. So we have to use the product rule to take the derivative. The derivative of the first factor is x, the second factor is 3 to the x. The derivative of the first factor is 1 times a copy of the second factor, 3 to the x, plus a copy of the first factor, x, times the derivative of the second factor. The derivative of 3 to the x is the natural log of 3 times 3 to the x, divided by the derivative of the denominator. The derivative of 3 to the x is natural log of 3 times 3 to the x. The derivative of 1, of course, is 0. Notice here in this particular example, we're able to now factor out a factor of 3 to the x from the numerator. Both terms of the numerator have a factor of 3 to the x. So we factor that out, and we have 3 to the x times 1 plus x times the natural log of x. The natural log of 3. Divided by the denominator, we still have the natural log of 3 times 3 to the x. However, now we can cancel those factors of 3 to the x in the numerator and denominator. Once we do that, we now have left the limit as x goes to 0 of 1 plus x times the natural log of 3 divided by the natural log of 3. This is a polynomial, and so it's continuous. We can plug in the 0 to evaluate the limit. So 1 plus 0 times the natural log of 3 divided by the natural log of 3. 0 times the natural log of 3 is 0. 1 plus that is 1, so we end up with 1 divided by the natural log of 3 for our limit. So here we've used a couple of different techniques. One is we have used LHopital's rule because we had an indeterminate form, 0 over 0, initially. Then we factored and canceled to finish off the problem so that we could actually find that our limit is 1 divided by the natural log of 3.